Let us now focus on the networking aspects of ISONI, providing networking infrastructure as a service. ISONI provides networking connectivity among application components and to external networks like the Internet as requested and modeled in the VSN description, which is part of the DSLA negotiation as introduced before. ISONI supports best effort and loss-tolerant real-time traffic and allows to specify certain quality of service attributes with it. These quality of service attributes are related to bandwidth and especially for loss-tolerant real-time traffic like audio and video, to delay and jitter. The path management of ISONI takes care that the appropriate transport network resources are allocated. ISONI itself relies on different kinds of transport networks. These are best effort networks, routed IP networks providing different kind of QoS, and at least lines. Depending on the specified virtual link requirements, ISONI is in a position to lead the virtual link related traffic on capable network paths satisfying the QoS requirements as required by the customer. So, ISONI manages different kinds of available transport network resources against VSN deployments requested by the customer. In a successful case, all the required resources are reserved and allocated. Depending on the QoS attributes, the network traffic of deployed application uses individual appropriate network paths on heterogeneous transport network infrastructure. How ISONI is able to provide these kinds of QoS attributes for automatic deployments. Here an abstract network model is depicted showing the several VMUs and their network connectivity over physical hosts and node architecture hierarchy. As shown here, VMUs of the same or different deployments may share the same physical host. To avoid any impact of concurrent VMU traffic, the bandwidth of each virtual link has to be controlled, in other words, policed. ISONI follows the principle of managed infrastructure, which means that the network traffic load of each multiplexing stage is managed. A gapless policing ensures that multiplexing stages, so-called IXPs, always get a controlled load of traffic. Therefore, bandwidth policing is essential for ISONI to ensure QoS for individual virtual links. Any overload would cause unduly controlled growing of loss rate, delay and jitter, jeopardizing real-time applications. Also, non-real-time application data throughput, usually based on TCP, strongly decreases with growing delay and loss rate. The transport network paths carrying real-time traffic are continuously supervised using one-way measurements for loss, delay and jitter, especially on paths between ISONI nodes. This abstract network connectivity view has also been implemented in the prototype of IRMOS project. It shows the two transport networks of the testbed, one foreseen for carrying the best effort traffic, and the other foreseen for real-time traffic. For each path, the health status is supervised by doing one-way delay and jitter measurements. Also, the loss rate of the test traffic is measured. Status aggregation of the path health simplifies the general view. This view is not very practical in day-to-day operation, so the next view is more useful. The best way for a general view of internet network connectivity offers a connectivity matrix. Each intersection point represents the possible connectivity between ISONI nodes in general. This view represents the prototype health status graphical user interface. The first three nodes, A, B and C, have two interfaces, one for accessing the best effort network and the other for accessing the real-time network. The points of intersection represent the path health status of ISONI paths, which represents the path measurements for delay, jitter and loss as introduced before. Node D represents the transit node for accessing the Internet. Therefore, node D just has one interface carrying best effort traffic. The reachability of VMUs by assigning public IP addresses is supervised by ISONI as well as the reachability of external resources for which deployed application relies on. To be able for detecting any outages or connectivity problem inside a node, also operational and reachability status of each node is supervised by ISONI. The status entry represents the physical host of a node. Finally, on the right side, the availability of network resources per QoS class is indicated, which will be part of the next version of implementation.